Hey everybody, hope you guys are all doing great. Today we're going to work on the last section of chapter 11 to 4. We're going to do problems 89 and 90, and the homework is problems 100 through 106. Okay, so for 89, I'm going to read the ebook to you. It says, in your work with parabolas, you've developed two forms for the general equation of a quadratic function. Y equals ax squared plus bx plus c, and y equals a x minus h squared plus k. What information does each equation give you about the graph of a parabola? Be as detailed in your explanation as possible. When is each form most useful? Okay, so this form we call standard, and this form we call graphing or vertex form. And if you guys remember, we needed to complete the square on this side of the equation to get this to go back and forth, and we did that in Math 2 in the beginning of this year, but that's not what we're here for. What we want to do is take a look at these and talk about which one is best in which situation. Okay, so to start with this standard form, the easiest thing that I notice is that C is the y-intercept. So if you're looking for the y-intercept, standard form is the easiest. You can just get the constant on the end. A is the stretch factor. Okay, otherwise it takes a little bit of work to graph. If you're looking for the x-intercepts, this is the form that you want to be in. You can get the x-intercepts pretty easily by factoring with diamond and box or quad formula. And then to get the vertex, you would need to, you would add the average, hold on, average the x-intercepts and plug back in to get y. And that's something we've done quite a while ago, but that's kind of standard form in a nutshell. Okay, graphing or vertex form, well, you can tell from the name of it what its features are. First of all, the vertex is extremely easy to find. It's HK. A is still your stretch factor. It's not as easy to find the x-intercepts. You actually have to multiply this out with a box to get it to standard form, and then go through this process, averaging the x-intercepts and plugging it back in and factoring or quad formula. But a sketch graph is very easy, just to graph the vertex and then graph off of the stretch factor. Okay. And number 90 is going to be notes. And it's equation of a parabola given 3 points. I want you guys to kind of picture 3 points graphed, 3 separate coordinate points. And what we're going to do is try to fit a parabola to those 3 points. The points we're going to work with are 1, 0, 2, 5, and 3, 12. Okay, and we are going to find the equation in standard form. And so at the end, our answer will look like this. Okay, what I'd like to do over to the side, very roughly, is sketch 1, 0, 2, 5, and 3, 12. And I want you guys to kind of think about visualizing the equation of a parabola that might go through those 3 points. Okay, so if you need more practice with systems of 3 equations, now is your time, because the way to solve this is actually to plug it into an equation with three unknown variables. So if you're still working on that, this is perfect timing to practice that further. Okay, so first thing I want you guys to do is label the coordinates x, y, x, y, x, y, just maybe for your first couple of times. And then what I want you to do is think about the standard form equation. So y equals ax squared plus bx plus c. Okay, what we're going to do is plug each one of these equations in for x and y in this, in a list, a vertical list, and then we will have a systems problem. Okay, so step 1, plug in x, y coordinates to make a system. Okay, so let me show you what I mean by that. So I'm going to take this first coordinate, 1, 0. Y is going to become 0. So I have 0 equals a, and then x is going to become 1. And I want you to specifically write it like this, where the exponent is outside of parentheses for that 1. So plus bx plus c. Okay, now we're going to do the second equation. 2 equals, nope. 5 equals a times 2 squared plus b times 2 plus c. Y, x, x. 12 equals a times 3 squared plus b times 3 plus c. Okay, and then the next step, I'm sure you guys can see, is just to clean this up a little bit. So we have 0 equals, I'm going to do the top equation first. 1 squared is 1, so I have a plus 1b plus c. Okay, 5 equals 2 squared is 4, 4a plus 2b plus c. And the last one is 12 equals 3 squared is 9a plus 3b plus c. Okay, so now this looks exactly like the notes we just did with a system of 3 equations. Okay, so the good part about these problems is that you don't ever plug anything into C because it doesn't have an X or a Y on it. So the C's are always just C's. So we are always going to have step 2 be the same. You don't have to think about what's the easiest thing to eliminate because it's always C. So step 2 is eliminate the C's with subtraction. Now, you need to use subtraction because they're all positive. So in order to cancel out the C's, you need to make sure to subtract so you have one positive and one negative. Okay, and I always group them the same. I do 1, 2, and 1, 3. And especially because equation 1 is so simple, it'll make it easy to work with. So 0 equals A plus B plus C. 0 equals A plus B plus C. 5 equals 4A plus 2B plus C. 12 equals 9A plus 3B plus C. Okay, so we're going to use subtraction, so I'm going to put parentheses around the bottom equations and subtract. Negative 5 equals negative 3A. Remember, this is A minus 4A, B minus 2B, and then the C's will eliminate. Negative 12 equals negative 8A minus 2B, and the C's will eliminate. Okay, so at this point, I am going to line them up. Negative 5 equals negative 3A minus B. Negative 12 equals negative 8A minus 2B. Okay, and so step 3, you're going to actually have to give some thought, depending on which is easier to eliminate, A or B. If you look at the A's, you have a 3 and an 8, which is kind of yucky. This is much better. I have a negative 2B and a negative B, so I'm going to multiply the top equation by negative 2. I'm going to make this a positive 2B and a negative 2B that will be easy to eliminate. So eliminate either A or B, depending on what's easier for your problem. So I have 10 equals 6A plus 2B. Negative 12 equals negative 8A minus 2B. Negative 2 equals negative 2A. 1 equals A. Okay, now step 4 is to plug in. And we still need to get B and C. So the plugging in is the same as the previous notes. I'm going to plug into one of these two, and it doesn't matter which one. I'm just going to use this one because there's room right here. Negative 12 equals negative 8 times 1 minus 2B. Negative 12 equals negative 8 minus 2B. Add 8 to both sides. Negative 4 equals negative 2B. 2 equals B. Okay, and then I'm going to plug into one of the originals. So notice equation 1 is the simplest. So I'm going to plug back into equation 1. 0 equals A plus B plus C. 0 equals 3 plus C. Negative 3 equals C. Okay. So this is not the final answer. I do have what A, B, and C are, but what I need to do for my last final answer is take A, B, and C and plug them into the standard form so that I can see the equation of the line. So y equals 1x squared, ax squared, plus bx plus c, and I'm going to put minus that. So if you guys want to clean that up, that's a perfectly good final answer. Or you could say y equals x squared plus 2x minus 3. And there's the equation of the parabola that goes through those points. Okay, now just for fun, and this is what won't be required on your problems, I'm sure, but this is a great way to check. So x squared plus 2x minus 3. So let's just look at the graph real quick. You guys can see it. My Cam hates the graphing calculator for some reason. Okay, so that looks good in comparison to my little sketch over here. You can do it, camera. Okay, and as great as that is, let's look at the table. Okay, so do we have 1, 0? Yes. 2, 5? Yes. 3, 12? Yes. So we know we got the correct answer. Okay guys, that's it for that section and it for chapter 11. I'll talk to you guys soon. Hope you're having a great week.